All right, so our first definition for this chapter is going to be a generalization of a K-automorphism. So how are we going to generalize it? We're going to generalize it to a K-monomorphism. So suppose K is a subfield of fields M and L. And if you like, these are subfields of C if you want to specialize to that. A K-monomorphism is a special type of monomorphism. And K-monomorphism is a field monomorphism. So again, it's a special type of monomorphism. Phi from M to L, such that, well, K, the fact it's a K monomorphism and K is a subset of both M and L is, what we're going to say is that it should fix K pointwise. Okay, so we say phi fixes K, and actually the notation in the book, the terminology in the book is not correct. So we say fixes K pointwise. All right, so let's look at an example of this new definition. We've seen that there exists, oops, let me fix that color. There exist monomorphisms from Q adjoint alpha to C, where alpha is the real cube root of 2. In fact, we saw that there exists 3 of them. So we have, let's say, phi 1, which takes P plus Q alpha plus R alpha squared to itself, just viewed as an element of the complex numbers. There's phi 2, that takes that to P plus Q omega alpha plus R omega squared alpha squared, where omega is a cube root of unity. We can take the standard primitive one if we'd like. And then there's another one to the where it takes alpha and sends it to the last cube root of 2, omega squared alpha. And there are these 3 monomorphisms, and we've constructed them. We've shown their monomorphisms, or some version of this is a monomorphism, already a bunch of times. And notice each of these fix Q, because how is Q a subfield of Q adjoint alpha? It's given by this P term, right? P, if all of the other guys are 0, if they didn't exist, this is the map P goes to P. Phi 2 is the map P goes to P. Phi 3 is the map P goes to P. So each of phi 1 through phi 3 as maps from Q adjoint alpha to C are Q monomorphisms. And that's an example. And we generalize this slightly for some of the theorems we're going to need to prove in this chapter on finite normal extensions. And so, this might be getting kind of redundant, right? We've been studying things like this basically since day 1. But it is helpful to introduce this slightly more general language of a K monomorphism. So here it is.